Yeah. And remember, what is rate? Rate is, generally speaking, comparing two units of measurements. Two units of measurement. For example, speed is a rate, because what are we comparing when you talk about speed? You're comparing, miles are compared to mph, miles per hour, which means this, miles per hour. Okay, and when we talk about rate, sometimes, frequently talk about unit rate. And when they ask you for unit rates, the word unit in your mind should, Mrs. Smiley, I just have the ones from my class.
That's fine.
Will that work?
That's perfect.
This one she can recheck the status on that and ask for a 46 one.
The word unit should make you think of what? Anybody? Sage, the word unit means
Like something,
one, per one. In other words, when we talk about miles per hour, we talk about how many miles per 1 hour. We don't say you went 50 miles per 6 hours, we say you went 50 miles per 1 hour. So when they talk about unit rate, you need to get the bottom needs to be 1. For example, let me give you an example of that. If 6 books weigh 15 pounds, if 6 books weigh 15 pounds, comma, what is the unit rate? Now, here's where Jeremy Schwartz has to ask himself, because I've got two different things here, right? I'm comparing books to pounds or books to weight. The question you need to ask yourself is, do I put books on top over weight, or do I put weight on top over books? Because you could write the fraction either way. So, Sage Hyde, you have to ask yourself, what makes more sense? If I go to the store, if I put a 1 on the bottom, do I ask the store how many books I can buy per pound? Or do I ask a person how much a book weighs, how much one book weighs? What is the weight per one book? I mean, if you're talking about that. Which one would make more sense? How many books you can buy per pound, or what the weight of one book is? Sage? Right. So unit rate, you're going to be talking about this. It weighs 15 pounds for 6 books. Now, how in the world would you find out how much it weighs for just one book, Jack?
You divide.
Yep, you're just going to have to divide it. And this one doesn't work out evenly, but it'll be fine. 6 goes into 15 twice. 6 goes into 30 half or 5 times. So the unit rate is 2.5 pounds per book. Just like when you go into a store and you look at the little tags, okay, would it make sense if instead of how many cents per ounce, they flipped it around and asked you 1 ounce would cost how many cents per ounce? How much you can buy per 1 cent? How much of a can of pop do you suppose you can buy per cent, per 1 penny? Well, you have to be able to buy some part of it for a penny. I mean, if it costs you 50 cents a can, and there's 12 ounces in a can,
the
thingies.
Let's do it here. Let's do it that way. If you did it here, let's look at the goofiness of this, just because it would be fun. If a can of pop in the store cost you 50 cents per 12 ounces, which is what a can is. Okay? You could either figure it out two different ways. You could figure out how much cents it is per ounce, or how many ounces you get for 1 cent. Let's look at the different ways. This case, you put 50 cents, you put 50 cents over how many ounces? 12 ounces. So you do the math, 12 goes into 50 what? 4 times, that's 48. Well, let's do it. 12 goes into 50, how many times? 4 times, that's 48. 12 goes into 20, 1 time. 12 goes into 80 about how many times? 6 times? Let's just say, so this for this first one, we get it, you spend 4.16 cents per ounce. Okay, that's the unit rate when you have cents on top. If you flipped it over and did it the other way, this one you're figuring how much pop you can buy for 1 penny. Okay, so you have 12 ounces on top, 50 on the bottom. You divide 50 into 12. You get 0.2, which is 100, 0.22. You get 22 hundredths of an ounce per 1 cent. So for 1 penny, you get like a fifth of an ounce, which would be what? How much is a fifth of an ounce? That's pretty close to a drop. It probably is. So sometimes you have to use your common sense to figure out, oh, that's not a problem. I can tell most of you are rather enthused about that. Must be getting close to Christmas vacation.
Oh, yeah.
What is this? Am I in the wrong one? No. Let's look at this one here, ladies and gentlemen, kids of all ages. Julio is riding in a 50-kilometer bike race. He passed the 15-kilometer mark in 27 minutes. If Julio continues to ride at the same rate, what will be his time for the whole race? Boom. I'll entertain a motion as to how to figure that out. Ooh, Lauren Daffenberg says, well, you can draw a picture for this. I would go for that. Although I don't know if it's necessarily going to get you where you're going. He's going, the whole race is what, 50 kilometers? 50 km. He passed the 15-kilometer mark. Here's the 15-kilometer mark. In how long?
47.
In 27 minutes. Now you could take a pretty good guess as to what should your answer be close to. If you did this much if you did 15 kilometers in 27 minutes, your answer is going to be close to what? Just guessing. Mickey Kala.
Like an hour and a half-ish?
Maybe an hour and a half-ish, because, well, this is that there. But this is a ratio, children, ladies and gentlemen, kids of all ages. If you sit here and do this, okay, if he did 15 kilometers, you're comparing kilometers to time. If you did 15 kilometers in 27 minutes, how long would it take him to go 50 kilometers? And this is what you don't know. You can write a ratio or a proportion or a fraction that is equal to that, because you're comparing this to this, so you compare that to that. They have to be equal. If you keep at the same rate, whatever it is. So you end up with 15 over 27 equals 50 over 10. Any suggestions what I could do to make this easier? Jeremy Schwartz? Does this reduce? Any number going to 15 and 27? 3. So I cut this by 3, I get 5. I cut this by 3, I get 9. What times 5 is 50? And what times 9? What times 10 is 9? 9 times 10 is 90. So whoever said the 90-minute thing tell us estimated 90 minutes, and that would be absolutely true. So you can set it up as a ratio in kind of a ratio box sort of thing there. Let's look at another one. We already did that one. How about this one? Yeah, same thing in this one. We already kind of did that. Well, let's look at it. Just because I can tell you're excited about this. If 6 books weigh 15 pounds, how much would 20 books weigh? Again, okay, they give you the ratio. And what are you comparing? You're comparing books to pounds. This is the actual. If 6 books weigh 15 pounds, how much would 20 books weigh? And again, you can do the same sort of fraction there. 6 over 15 equals 20 over n. What's the best thing to do there? Hannah Nuza, what can I do with 6 and 15? 2. 2 over what? 4 and 5. And then 2 times what is 20? 5 times 10 is? N equals 50 pounds. Does that make sense to anybody? Just nod your head in disagreement. Ready? One more. And then I'll set you free, and you shall be free indeed. Oh, do I have example 3? Where is example 3? There's Julio riding at 50 kilometers.
We just did that one.
He did 50, I know, but we need it for this one. No, where was it? This one. In example 3, what is Julio's rate in kilometers per minute? Now take a look at this. What do you see? They give you the fraction that they want. What is it? This. They want kilometers over minutes. So if you go back to Julio, what did it say? He did how many kilometers in how many minutes? He did 15 kilometers in 27 minutes. Okay, they want you to write what is his rate in kilometers per minute. What are you gonna have to do? Reduce this, divide it out. What do we get? This was 5 over what? 9. What does that give you as a decimal? You should know what that is. Yeah, he is doing 0.5 repeater kilometers per minute, which is close to a half kilometer per minute. Write the equation that relates Julio's distance to his time riding. Alright, I think we're good. Tell you're very excited about this. 7th grade, 4 tomorrow. For tomorrow.